you this question is June 4, and the top of the plane inclines 0.7 meter height. It means this is condition you have. Even I can erase this part and have a look here. Okay. So we have this kind of triangle, and this is 7 meter height, 0.7, sorry. And the other is a 2.5. So 0.7 and 2.5. I can find this easily, or I can say that sine theta is equals to what? This is the opposite by adjacent. Okay. So 0.7 over 2.5. And I can find easily. So sine so 7 over 25. 7 over, so sine theta is 7 over 25. And what is the cos theta? All of you know, I can find. So I can find it 1 minus a sine square theta equal to root. Okay. So it means that 1 minus 7 7 divided by 25 and square and take a root of that. It is giving me. Okay, this is coming 24 over 25. 24 over 25. Okay. So so this is very clear idea. After this, what a story we have according situation. You know it very well when an inclined plane is there. So particle is traveling and downwards. So if I apply, what is the situation here? 0.2 mass is given, start from release from rest. Again, you stop the speed at the top is 0. Again, it is a very, very clear approach. So I can say that, let's say I'm not given, I say this A and this B. So velocity at A is confirmed 0 because, and we know it very well. We know it very well. Velocity and applied force is 0. So work done by applied force is 0. And I think so smooth or rough, let me check. No, it's not smooth. The first part is saying smooth, second part is rough. So first part, I part, friction is not there. So work done by friction force is 0. Okay. And he's saying height is given by him is a 0.7 meter height. Okay. And what to find kinetic energy of the system bottom. So we need a kinetic energy. So first part is not a hard job because magic formula, because these two parts are 0. So naturally this will come on the left hand side. So I can say that mechanical energy at a kinetic plus potential energy at a B equal to kinetic plus potential energy at A. Kinetic energy B is my target. I'm leaving as it is. And potential energy at B is 0. I'm just writing 0. And K is 0. So I'm writing 0. And potential energy is mgh. And mass is given how much? 0.2. So mg is 10 and height is 0.7. So kinetic energy I got at B is so simple. And that is answer is coming. If I type it in calculator, simply it is becoming 2. So 1.4, 0.7 into, wait a minute, 0.7 into 10 into 0.2. So it is 1.4. 1.4 joules is very, very clear. And let's go for the next part. Part number 2, he said coefficient friction is given 0.15. And I discussed that F is equals to mu R. And mu is given by him is 0.15. But R is very interesting. I said before, particles placed here. Okay, I'm showing here. When particle is placed on the this one, so this is always, what is that? This is a, because mass is a 0.2, this become 2 sine theta. And this become R, you know it very well. This become what? 2 cos theta. This is a theta, as you said, as I said before. So I will take R is equal to 2 cos theta, and we know cos theta is 24 over 25. So it becomes 24 into 2, 48. So 48 over 25. So into 48 over 25. So if I check it, 0.15 into 48 over 25, it is giving me a simple value is 0.288. I repeat, 0.288 is a friction value. The friction value, we got it. Now, what a question he's asking. He is asking that again, kinetic energy at a B is target. So again, I apply magic formula, work done by applied force, work done by frictional force, kinetic energy plus potential energy at a B minus kinetic potential energy at a A. This is 0 for sure, and there's a F into D. F into D, small f into D. Okay, I write values directly. Small f into D. Small f is a 0.288 into D. Distance is a given 2.5 meters. 2.5, and kinetic energy is B is a target, and potential energy at ground level is 0. So I'm writing this directly 0, and this is kinetic energy is also 0, and potential energy is my target, and that is simple. mgh. Mass is a zero point 0.2, mass is 0.2, g is 10, and height is 0.7. So I think it's a matter of just typing in calculator. So, and that's it. So negative 0.288 into 2.5, and plus 2 times to 1 point, sorry, 0.7. And this is coming 0.68 kinetic energy. So I think the point is 0.68 joules. So I hope so. The point is very